This is the Water Quality Association podcast, promoting better water quality around the world. Hello, I'm your host, Wes Bleed.
Kristin called them forever chemicals. That's because they just don't break down very easily. So having strategies as an industry and as a country really on how we're going to get this out of the water and then stop it from getting back into the water is important. And I really feel like the industry has stepped up in a big way.
That's WQA's Laboratory and Facilities Director, Zach Gleason, talking about the new EPA rule on PFAS and drinking water. And welcome to the weekly podcast from the Water Quality Association, the leading voice of the residential, commercial, and industrial water treatment community. Find us at WQA.org. If you're a first-time listener or viewer, welcome. We're glad you're here. Be sure to subscribe to the podcast so you never miss a show. That's the magic of podcasting. And be sure to share the podcast with someone you know. We also feature our podcasts on YouTube. Go to youtube.com/@Water Quality Association videos to both see as well as hear our guests. In this episode, we dive into the EPA rule on PFAS. We'll head to Washington for a chat with WQA Government Affairs Director Jeremy Pollack. He fills us in on the details of what the EPA rule means for the water treatment industry and when it will take effect. Later, we'll talk with WQA Toxicology Director Kerstens and Lab Director Zach Gleason as we learn more about PFAS, what tools and resources the industry has to battle PFAS in drinking water, and how manufacturers can prepare now to have their new products tested and certified for PFAS removal. So all of this is coming up on this episode of the Water Quality Association podcast. Stay with us. We're going to be talking about PFAS in this WQA podcast, specifically the EPA's new rule on PFAS that was approved in April of 2024, and it sets a maximum contaminant level for 6 PFAS or PFAS compounds in drinking water, and really is the first ever national, legally enforceable drinking water standard. Let me bring in WQA's Government Affairs Director, Jeremy Pollack, to give us specifics about the EPA's rule on PFAS, to add some more color and detail to the EPA rule. Jeremy, welcome to the show. Thank you.
Thank you, Wes, and that's a great question. The EPA published its first national primary drinking water regulation for PFAS chemicals. And so this includes an enforceable maximum contaminant level for PFOA at 4 parts per trillion, PFOS at 4 parts per trillion, PFHS, PFNA, and Gen-X chemicals all at 10 parts per trillion each, along with a hazard index, which is a mixture of 2 or more PFAS contaminants. This is extremely important in combating PFAS in drinking water across the country, as these enforceable regulations will go into effect in 3 years, starting with municipalities and utilities having to monitor for these chemicals, then report to the public in their reports if these chemicals are in their water.
Okay, so that's very interesting. And when will this take effect?
Great question. The rule goes into effect starting in 3 years in 2027. By then, utilities and municipalities will need to monitor for these PFAS chemicals and report to the public if it's in their water supply. 2 years after that, so in 5 years from now, municipalities will then have to react by reducing PFAS if there is a violation. So if it's above the MCL amounts, they'll have to start providing some solutions within their plant or at someone's home.
All right. And what was WQA's role in the policy formation on this important rule?
Right. As a nonprofit association that aims to bring more awareness to water quality, it came upon us and our members to provide information on potential solutions, and feedback in general on the proposed rule when that was released. We talked about the feasibility of point of use and point of entry technology in combating PFAS. We talked about available technologies. We talked about national standards that are developed through the consensus-based process of ANSI, so those industry standards, and how those can be eventually updated, right, to meet the new rule. So a lot of that feedback is important to being a technical resource to the EPA and something that WQA strives for.
Was any of WQA's input let me put it this way, did any of WQA's input find its way into the policy?
Yes, so there was a lot of specific questions in the originally proposed rule regarding the use of point of use and point of entry for compliance under the Safe Drinking Water Act. These technologies can be used for smaller systems that serve 10,000 people or less. And so they wanted feedback on either cost, efficiency, et cetera, as it relates to those technologies. Additionally, our comments were used by the EPA in responding to other stakeholders when the rule was finalized. I'd highly recommend that if anyone who's interested in WQA's comments to go to our website where they're listed. We have a new one-pager that summarizes our comments to the rule and also some of the comments that EPA had echoed.
Excellent. Now, we know the manufacturers in the water treatment industry are taking note of this and are very interested, very focused on this, but dealers may not be, at this point at least. Help us understand why dealers should be interested in the new rule.
Right. So, although the rule is specific for compliance, right, of community water systems, that doesn't mean that the public is not going to seek solutions before then. So we have this 3-year lead up where public and community water systems are going to be monitoring for these PFAS chemicals. And as a result, people are going to learn more and hear more about the impacts of these contaminants. And they're going to want solutions not 3 years from now or 5 years from now. They're going to want solutions today. And so by pivoting your business and being aware, right, of what the public is seeing and hearing and helping them understand that there are solutions available is a huge opportunity for our members, especially those in dealers who are those boots on the ground in these communities who can actively help these folks. And so again, as we see over the next 3 years, more information comes out about how widespread contamination may be in certain areas, and especially with that gap of 2 years between the reports that include PFAS and then the actual solutions from utilities, a lot of people on their own will likely seek solutions.
Yes, and then long term, how do you see this playing out, Jeremy?
Yeah, it's always hard to predict what the EPA is doing, but I think this is the first of several regulations we'll see down the line. They've been fairly active recently, including on lead. They're updating their lead and copper rule, which is another rule that WQA has been commenting on. I think that the attention to this contaminant will continue to grow, and they will work on additional guidance. Rather, that might be around disposal of spent media or other types of guidance for smaller systems. There's a lot of additional work that will happen around this rule over the next few years.
To talk about that with us, we've got Kristin Kerstens, who's the Director of Toxicology for the Water Quality Association. Also in this segment of the program, we have Zach Gleason, who is the Director of the Laboratory at WQA. So welcome, both of you. Appreciate you joining us.
Thank you, Wes.
Hey, Kristin, maybe we start with you just to kind of get that high-level view of PFAS. Tell us about what it is and why we should be concerned.
Yeah, so PFAS has been referred to as forever chemicals, ones that really don't break down naturally in the environment. The major health concerns associated with them is that they have what's referred to as a constellation of effects. There's lots of different issues that have been noticed in animal testing and human epidemiological studies. The several that the EPA have recently regulated, a few of them have been determined that they have cancer effects. And a few of them they've grouped together in a hazard index because they have similar effects on the human body. So they've been measured as a mixture instead of individually, as we've traditionally done with human health chemical risk assessments.
And help us understand the significance then of the new rule from the EPA.
Well, this is huge because these compounds have been around since the 40s, and they're everywhere. They're in public drinking water supplies, they're in well water supplies, and they're at really low levels. They're measured at really low levels, health effects. And so we have to look and have products that can remove these chemicals down to really low levels.
Well, and Zach, as you listen to Kersten's description, this is something you've been paying attention to for some time, right?
Yes, yeah. So just keeping track of occurrence, always trying to watch for emerging contaminants, following the UCMR studies, and trying to stay ahead of the curve so that we can keep our clients and the industry informed. I would say part of the significance of the EPA taking a stance is that, as we know, it takes a long time for the EPA to make decisions like this, right? So this was probably actually one of the faster decisions I've ever seen them make, which shows its significance. And then as Kristin talked about, right, the ubiquitousness, it's really kind of everywhere. So it's an important one for people to be aware of and take seriously. And I think just the levels that they set and the movement to a very health focused, like the health impact focus, the way they're taking the hazard index and looking at, water chemistry is getting more and more complex, and our understanding of its impact on health is getting more and more complex. So that's reflected in that hazard index, where you can have maybe one that's high and one that's low, or all medium. And really what matters is the combined impact on your health. So, and this is the first time we've seen that out of the EPA too. So I think that that's also a significant thing to pay attention to.
And Kristin, the impact is also interesting because the nature of the science is, as Zach alluded to, we're finding out more and more about these chemicals all the time, and so the rules, the regulations, all of that's going to be an ongoing process, right?
Yeah, it's challenging because the several PFAS compounds that have been used for a long time are longer chain compounds, more carbons and hydrogens connected to each other, whereas the more recent PFAS compounds that have been used on the market are shorter chain. So the impact on that is it takes different technologies, or technologies act differently when they remove these compounds. So there's not one option to solve all PFAS compounds. It's many different technologies and approaches to remove them, as well as impacting your body differently, the different size compounds.
So let's kind of dive into the question of what can the water treatment industry do regarding PFAS? What are the solutions that are available, and how do we keep track of, again, what those solutions are? Zach, can I start with you on that?
Yeah. So a lot of what's good news, right, is that a lot of the traditional or more well-known technologies are proving to be effective. Activated carbon, ion exchange resin, and RO are kind of the trifecta that we see used for organics or carbon-based molecule removal, and all of them have differing degrees of effectiveness, which is great news, right? Because if it was everywhere and in very sensitive to our bodies and we couldn't get it out, that would be terrifying. So it's encouraging that we can effectively remove it. And the follow-on question that's coming up now is, okay, well, I'm removing all of this with my carbon filter. Isn't all that PFAS ending up in the carbon? And the answer is yes. And that's why WQRF and WQA are working on proving out and looking at the leaching, right? So we have that ongoing study looking at, well, what happens when we throw that carbon away? And those have been pretty favorable results as well. And then more and more research is being done on how do we destroy these chemicals. They're really, Kristin called them forever chemicals. That's because they just don't break down very easily. So having strategies as an industry and as a country, really, on how we're going to get this out of the water and then stop it from getting back into the water is important. And I really feel like the industry has stepped up in a big way to address that. And you can already see the impact if you look at the UCMR3 versus the UCMR5. That's where they go out, they collect water samples from all over the US, and they look at prevalence of what they think might be emerging contaminants. UCR3 had a few PFAS compounds on it. UCR5 has even more, and you can see a drastic decrease in the concentration of PFAS molecules that they're finding, which is great news, right? It means all of the cleanup effort that is going in by the manufacturers of the products where they're using this material, the Air Force's bases where they're using this flame retardant stuff, and then again with cleaning up the water that's already been going on, we're already seeing improvement, which is very encouraging to me.
So Zach, what challenges do laboratories like the WQA lab face in testing for PFAS and the new limits set by the EPA rule?
Yeah, so I think, I guess to tie that into your last question, really, that's part of what WQA is doing too, right? And what the standards committee is doing is developing a standard that has meaning for the consumer so that they can have confidence that their product is removing these chemicals. So, always encourage people when they're buying a product, if they're worried about a chemical, to really look for that certified product. So I just kind of want to reiterate that first. But as far as challenges that we're facing, lots of new technologies, right? Some brand new approaches to removing chemicals are coming through the lab, and that means we want to put those through their paces and make sure that we're testing them in the appropriate way, and adapting the standard quickly is a big challenge there because we need consensus and we need to understand how these things are working. The other challenge is like Kristin talked about, these are very low levels, PPT, and ideally 0 is the goal on some of these. That's just detecting that is problematic, and getting consistent, accurate results, and not having contamination from outside sources, right? Because these are forever chemicals that we find everywhere. They're in waterproofing, they're in flame retardants. A lot of the lab coats we wear, they have built-in flame retardant because they're meant to keep people safe. And if I'm working with a flame to adjust and boil or whatever, I want to have a coat that's going to protect me against it catching fire. Well, if it has PFAS in it and I'm testing water for PFAS, now I have a potential contaminant source. So just rethinking all of the raw materials we're using in our approach to controlling those contaminants, and then making sure we're staying on top of the best methods for how we detect these things and try to keep the cost down. Not just for us, but for everybody, right? If it costs $400 to run one sample for PFAS, it gets really difficult for us to make a lot of progress because nobody can afford to just pay for infinite numbers of samples. So always working at driving those costs down too.
Kristin, will the certification process change with this new EPA rule in place?
Yeah, absolutely. And actually, the EPA ruling in place takes away a lot of uncertainty that we've had for the last couple of years. We can develop with the Joint Committee reduction protocols and to remove, these certain chemicals, but ultimately the regulation paves the way for us to determine what chemicals at what level. So it's also important to understand that there's two main types of testing that manufacturers could have done as these new laws are implemented. So the first type of testing, as you mentioned earlier, is performance type testing. That's a product's actually going to remove it. So Zach touched on a couple different technologies. We're going to actually test those products. We're going to make a tank with PFAS. We're going to run the water through the products, and we're going to measure the level after the fact. Now that we have those levels set and we know what compounds it is, the Joint Committee will be working very soon to get those compounds and levels published in the standards, so there can be reduction claims that all manufacturers can go after for those regulated compounds. The other type of testing that maybe hasn't been discussed as much is material safety or extraction testing. So we want products that remove these compounds, but the reality is there's products out there that have these compounds in them. And we've been looking for the last couple of years, quite some time, for PFOA and PFAS from materials that drinking water treatment products or components are made out of. But we haven't been necessarily looking for all of these other compounds that the EPA regulated with this ruling. So that's going to change for all the product testing labs as well, is that we're going to start looking for many more PFAS compounds that we have in the past. And early indication from our lab is that a lot of these products do have these chemicals in them. And so we don't want that. That's material safety extraction testing. We want to make sure that these products are not adding chemicals to the finished drinking water. And so all products require material safety extraction testing. Not all products require the performance reduction claim. So we're going to have to be deciding in the industry how quickly manufacturers can get their products tested to remove to see if they have these compounds coming out of it. And that's also in the process of being finalized with the Joint Committee right now. We just have a ballot that's open in regards to adding all of the regulated compounds, plus an additional few that will be wrapped into the hazard index that we have levels for. So that ballot closes shortly. And the next step then is what materials should we be looking for these compounds in? And the early indicator for anyone who's interested is that they can look at NSF ANSI CAN 61, table 3.1. Right now, it's indicated in this standard that PFOA is what we're looking for. And that's going to change to these extended compounds of chemicals. So if a manufacturer wants to know what materials they might have in their product that would be impacted, they could look at table 3.1 right now, or they could reach out directly to Zach or I, and we'd be very happy to help you get some early testing done before these requirements go into the standard so that manufacturers can get ahead of reformulating their products to remove these chemicals.
But of course, right, if I'm wanting to get ahead, even from a marketing perspective, right, getting this stuff done early is going to give you a significant advantage in the market because the consumers are aware of the issue. And also, if everybody comes to us at once and wants testing, you're going to end up in a line. So just trying to encourage people to get ahead of the curve as much as they can.
And as Kristin was talking about manufacturers and what they need to be thinking about, Zach, and just to pick up on what you just said, what would you be kind of laying out as sort of the game plan right now for anyone thinking about bringing a new product or testing an existing product?
Yeah, I think Kristin's right. I think starting with the material safety extraction testing is always best because, if you end up needing to change materials as part of that R&D testing, we can work with you on that. Then you're going to not need to repeat it when you come for final certification. If you start with the performance testing and you change something about your product, you might have to redo that. So we would always encourage people to kind of start with that material safety extraction testing.
And last question for you both is just kind of the long-term outlook. How do you see this affecting the water treatment industry in general, or throw out a specific over the next 5 to 10 years?
I can go first, I guess. So, coming out of COVID, really, I see more and more people that are more and more health conscious and more taking responsibility for their own decisions. And I see PFAS as another push in the same direction, right? It's impossible for centralized water treatment to keep up with all of the emerging contaminants all of the time. It takes time to deal with things as we find them. The point of use, point of entry market can be much faster, more reactive. And so I see a continued increase in awareness of what's in my water and how do I maintain my health at an individual and household level. And I see an increase in our specific target industry because of that. I really do think that that's the future, especially just looking at the drama we deal with lead plumbing, and how expensive it is to fix all of that. It's another example where this huge infrastructure approach to things, it's just very difficult to maintain sustainability and cost effectiveness. So I do think that we will continue to see a shift towards valuing treatment right at the tap, that final barrier, which is what WQA is all about.
Kristin?
Yeah. If I could just piggyback on that, that's what I was thinking was the final barrier concept. This is really a set of contaminants that shows how important that is. If we're only consuming 1% of the water that comes into our home, the easiest solution is to get a POU, point of entry type product that can remove these compounds from your home. And we have several products already certified to the, existing levels in the standard that are showing that they can remove these contaminant. So getting one of those today or tomorrow can alleviate some concerns. Another point I guess I wanted to make is that it's really an option today, now, to test your product. We have ongoing testing happening in our lab for other extraction. We can add on an R&D testing to look for these additional compounds today, now. So it's not even like you have to get in line. You can just ask for us to add it, and we can get going today on evaluating your products for extraction testing. And it's really not going to be that much more if you're already testing your product for extraction, because the lab's already setting up the product and running all the water through it. We're just adding a little bit of additional analysis on it. So we're not anticipating it's going to be very expensive for manufacturers to get the data they need to determine what they need to do to adjust their products.
Well, on that hopeful note, I want to thank you both for joining us. Appreciate it.
Thank you.
Great to be here.
Thanks for joining us for this episode of the Water Quality Association podcast, where we bring you the latest news and insights from the association, our members, and outside experts to help you better serve your customers and grow your business. Learn more about water and water filtration at our consumer website, betterwatertoday.org, and learn more about professional certification, product certification, and how you can become a member at WQA.org. Until next time, this is Wes Bleed. So long from the Water Quality Association.